friction is required for pretty much everything we do. You couldn't walk, drive, or even sit down if there weren't any friction. And sometimes it's useful to think about idealized frictionless situations, like we'd been talking about previously. So we're pretending that there isn't any friction when we're talking about very basic concepts. But as we get deeper and deeper into understanding Newton's laws and forces, then we need to start describing them in terms of actual forces, and that would include friction. So we have two different types of friction. We have static and kinetic. Sometimes we even include rolling friction, but we are not going to talk about that one quite yet. Static friction occurs when things are at rest or not moving. Kinetic friction would be when objects are moving. So an example of something that has static friction would be a book sitting on top of a table, whereas kinetic friction, that book would be pulled across the table. So there would be friction here in between the surface of the table and the book. When the book is at rest, it would be static friction, and when the book is being pulled, it would be kinetic friction. So this static friction is the type of friction that is a force that a surface exerts on an object to keep it from sliding across the surface. So keeps from sliding. So let's talk a little bit more about each of these kinds of friction. So let's talk about static friction. Remember that it is a vector because it is a force. Determining the magnitude of static friction is a little bit difficult. If we're talking about a box on the surface of the ground, because the box is at rest, it is in static equilibrium. So if we were to draw a diagram, here's our box, here is our box at rest on the ground. It's at static equilibrium, meaning that all of the forces are equal and that it's not moving, it's not accelerating. So if we were to draw a free body diagram representing this box as a dot, we would have the force due to gravity, which is its weight, its normal force, it being pushed by someone, and the force of static friction. So if all of these vectors are balanced, all of these forces are balanced, then it would be at static equilibrium. So we have to think about static friction in terms of how much force the person is applying. So as the person pushes harder on the block, the static friction must increase in response to that applied force until the block starts moving, and then we would be talking about kinetic friction. So most often when we're talking about static friction, we talk about the greatest force that a person could push without the block moving. To calculate this value, so this is our static friction, and that would be its maximum. So remember, again, that's the maximum static friction that this block and surface combination could have right here without the block moving in response to this applied force by the person pushing on the block. This maximum static friction force would be mu s n. And this mu s is the coefficient of static friction, and n is actually equal to our normal force. So the higher this coefficient of static friction, the higher the stickiness between the object and the surface. So if a wooden block was sitting on sandpaper, it would have a higher coefficient of static friction than if it was a wooden block on a piece of aluminum. So there are some rules for static friction. First, static friction opposes motion. Second, the magnitude of static friction adjusts depending on the applied force. And it adjusts itself so that the net force is 0 and the object doesn't move. And lastly, the magnitude of the static friction cannot exceed the maximum value of static friction. So hopefully you have that all written down. If not, pause here and get all those notes down. We're going to move on to kinetic friction, and surprisingly, it's a little bit easier than static friction. So with kinetic friction, it is when an object is moving. So now we're going to be talking about kinetic friction. And this also opposes motion. But unlike static friction, it is nearly constant in magnitude during the object's motion. So it doesn't depend on the applied force. So our equation is a little bit simpler just because the kinetic friction doesn't change. And the equation looks so similar to static friction. We have our force, our kinetic friction force is equal to our coefficient of kinetic friction multiplied by the normal force. So the cool thing about kinetic friction is that the magnitude of kinetic friction doesn't depend on how fast the object is moving. So there are some of the basics on friction.